Okay, this is part 244, line 22e5, Lithium Electrophile Trifluoromethyl Hypofluorite 5G Wow Seti. If you're looking at line 22, I'm going to suggest you start with 22a. There's lots of videos before this one, and you want to go through A, B, C, D, E, and E at the moment, as of June 24th, is going up to E11, okay? And they're all related to one another because I broke up the data into smaller videos. So here's the alien radio signal. This is the date that I was working on it, June the 11th. Today is the 24th of June, 2012. Keywords from line 22E4. Lithium hypofluorite, keyword lithium. So I'm going to Google lithium hypofluorite. Lithium, of course, came up at the very beginning of the series here. And that was one of the components they use supposedly in the outer shell of the UFO. And when I find this hypofluorous acid plus it decomposes explosively at room temperature to form HF and O2. Quote from Wiki. Hypofluorous acid is acetonitrile generated in situ by passing gaseous fluorine through wet acetonitrile, serves as a highly electrophilic oxygen transfer agent. Treating phenanthroline with this reagent yielded the previously elusive 1,10-phenanthroline dioxide, more than 50 years after the first unsuccessful attempt. So I guess for 50 years they tried to do something, and I guess they finally figured out what to do, maybe. Google electrophile. Quotes from Wiki. In chemistry, an electrophile, literally electron lover, is a reagent attracted to electrons that participates in a chemical reaction by accepting electron pair in order to bond to a nucleophile. Now, we talked about bonding in 22C and B, I believe, so it's kind of cool how these videos progress. That's why they're all connected. Because electrophiles accept electrons, they are Lewis acids. See acid-base reaction theories. Oh, more theories, okay. Most electrophiles are positively charged, have an atom that carries a partial positive charge, or have an atom that does not have an octet of electrons. The electrophiles attack the most electron-populated part of one nucleophile. The electrophiles frequently seen in the organic synthesis are cations, such as H plus and NO plus, polarized neutral molecules such as HCl, alkyl halides, and acyl halides, and carbonyl compounds. Polarizable neutral molecules such as Ci2 and Br2, oxidizing agents such as organic paracids, chemical species that do not satisfy the octet rules such as carbenes and radicals, and some Lewis acids such as BH3 and dibol. Introduction, American Chemical Society publication, so it's from pubs.acs.org, by C.J. Hoffman in 1964. This PDF came up. It's inactive to trifluoromethyl hypofluorite at temperatures below 470. Trimethyl hypofluorite reacts 56 at room temperatures with mercury and with lithium. The reactions of triomethyl hypofluorite with sulfur trioxide. Another pubacs.org document from W.P. Van Meter, 1960. Hypofluorite 6005 lithium thereby effectively reducing the concentration of free lithium alcohol because of the rapid attainment of equilibrium between them. So Google trifluoromethyl hypofluorite. I wanted to know what it meant. Okay, so triomethyl hypofluorite is an organofluorine compound. With the formula CF3OF, it exists as a colorless gas at room temperature and is highly toxic. It is a rare example of hypofluorite compound with OF bond. It is prepared by the fluorination of carbon monoxide. And there's the calculation there. The gas hydrolyzes only slowly at neutral pH. So there's the graph. There's another graph. I think that's the end of that one. Oh, nope. Uh-oh, you know what I did? I goofed. Oh, somehow I goofed you. Okay. Quotes from Wiki. DNA nanotechnology involves the creation of artificial designated nanostructures out of nucleic acids such as this DNA tetrahedron. Each edge of the tetrahedron is a 20 base pair of DNA double helix, and each vertex is a 3-arm junction. I'm sorry. I actually divided this lens up into the other 6, and somehow I missed some parts of it and I got confused. So this use is enabled by the strict base pairing rules of nucleic acids, which cause only those portions of nucleic acid strands with complementary base sequences to bind together to form strong, rigid nucleic acid double helix structures. This allows for the rational design of base sequences that will selectively assemble to form complex target structures with precisely controlled nanoscale features. DNA is the dominant material used, but structures incorporating other nucleic acids such as RNA and peptide nucleic acid (PNA) have also been constructed, leading to the occasional use of the nanonucleic acid nanotechnology to describe the field. A molecular photonic and gate based on fluorescent signaling. This is from these different scientists here. Abstract. The molecules that perform logic operations are prerequisites for molecular information processing and computation. We and others have previously reported receptor molecules that can be considered to perform simple logic operations by coupling ionic bonding or more complex molecular recognition processes with photonic fluorescence signals. In these systems, chemical binding, the input, results in a change of fluorescence intensity, the output from the receptor. Here we describe a receptor molecule in Figure 1 that operates as a logic device with 2 input channels. The fluorescence signal depends on whether the molecule binds hydrogen ions, sodium ions, or both. The input-output characteristics of this molecular device corresponds to those of NGATE. And that's www.nature.com. So June 11, 2012, my thoughts. The keywords are molecules plus computation plus chemical binding plus signals plus intensity plus receptor plus binds energy hydrogen ions plus sodium ions plus photonic. Are all keywords found in line 22e Wow data. The main thought here is signaling and molecules produces chemical bonding with hydrogen ions. Google these keywords to see what comes up. Signaling plus molecules plus chemical bonding plus hydrogen ions. And this comes up. Covalent bonds, ionic bonds, hydrogen bonds. Chemistry from Wysant. And it's wysant.com. Bonds hold atoms and molecules of substance together. Chemists also recognize hydrogen bonds as a fourth form of chemical bond, although scientists do not have an exact value to signal an ionic bond. So I Google signal an ionic bond to see what comes up. Ligand biochemistry. In a narrow sense, it is a signal triggering molecule binding to a site on a target protein. The binding occurs by intermolecular forces such as an ionic bonds, hydrogen bonds, and protein alters its chemicals, blah blah blah. Ligand biochemistry. In biochemistry and pharmacology, a ligand, from the Latin ligadum, binding, is a substance, usually a small molecule, that forms a complex with a biomolecule to serve a biological purpose. In a narrow sense, it is a signal triggering molecule binding to a site on a target protein. The binding occurs by intermolecular forces such as ionic bonds, hydrogen bonds, and van der Waals forces. The docking association is usually reversible dissociation. Actual irreversible covalent binding between a ligand and its target molecule is rare in biological systems. In contrast to the meaning in metal organic and inorganic chemistry, it is irrelevant whether the ligand actually binds at a metal site, as in the case in the hemoglobin. Ligand binding to a receptor or receptor protein alters its chemical conformation, three-dimensional shape. The conformational state of a receptor protein determines its functional state. Ligands include substrates, inhibitors, activators, and neurotransmitters. The tendency or strength of binding is called affinity. Radial glands or radioscope labeled compounds used in vivo as tracers in pesticides and for in vitro binding studies. Now it's very interesting with this graph, the way the swirls go and stuff. When I first started connecting the numbers in the wow signal, it made little squirrely lines like this. So, and then that's talking about binding and stuff and receptors, and then another keyword that jumps out there is neurotransmitters. So myoglobin blue with its ligand hemi-orange bound based on PDB1-MBO. Bivalent ligand. Bivalent ligand consists of two connected molecule ligands and are used in scientific research to detect receptor dimers and to investigate their properties. As usually, large compounds bivalent ligands tend to be not drug-like. What limits their applicability in clinical settings? See Lipinski's rule of 5. Receptor dimers. CPCR oligomer. A GPCR oligomer is a complex of a small number of G protein coupled receptors, which is held together by covalent bonds or by intermolecular forces. Receptors within this complex are called protomers, while unconnected receptors are called monomers. Receptor homomers consist of identical heteromers of different protomers. The existence of receptor oligomers is a general phenomena whose discovery has superseded the prevailing paradigmic concept of the function of receptors as plain monomers, and has far-reaching implications for the understanding of neurobiological diseases as well as for the development of drugs. So there's the extracellular and intracellular, and again we've got the different colored squiggly lines. When we put the different numbers on the wow, the very first time I did the wow, I did different colored lines for the different colored numbers, and it did different kind of shapes, kind of like that. Crystallographic structure of the human K-opoid receptor homodimer, 4DJH, embedded in a cartoon representation of a lipid bilayer. Each protomer is individually rainbow colored. N terminus is blue, C terminus is red. The receptor is complex with the ligand JD-TIC that is depicted as a space-filling model. Carbon equals white, oxygen equals red, nitrogen equals blue. Again, the three keywords there are carbon, oxygen, nitrogen. All three of those have come up in line 22's videos for fuel. Okay? So maybe this is showing you how the molecular properties of these components can be used in a fuel. I don't know, just guessing. So line June 12, 2012. See the keywords. Carbon plus oxygen plus nitrogen. I'm repeating myself here. They were in line 22. New keyword from GPCR oligomer data is crystallographic structure. So X-ray crystallography, June 12, 2012. Looking at the cube from the diamond's atoms reminds me of the cube matrix that comes up with the math equations for the central core of the UFO. Does graphite plus diamonds plus pure carbon plus cathedrally plus covalent bonds are all keywords in line 22 videos? Do they all have something to do with it? Well, all those components to be what you need to make the outer shell of your spaceship. Look how it goes in a circle there, right? And then it's got like a triangle thing on the outside of it. And maybe that's the way you're supposed to do it. Although diamonds, well, yeah, actually, because it was round in the middle and then it kind of had like this type of shape on the outside, like two triangles stuck together. Although diamonds top left and graphite top right are identical in chemical composition, being both pure carbon, X-ray crystallography revealed the arrangement of their atoms bottom accounts for their different properties. In diamond, the carbon atoms are arranged tetrahedrically and held together by single covalent bonds, making it strong in all directions. By contrast, graphite is composed of stacked sheets. Within the sheet, the bonding is covalent and has hexagonal symmetry, but there are no covalent bonds between the sheets, making graphite easy to cleave into flakes. So here again is our little cube matrix there with all the different atoms connecting. Unit cell, the diamond cubic crystal structure. So I'm wondering if you're supposed to use this type of structure for the outer shell or the inner part of the spaceship. The diamond cubic crystal structure is a repeating pattern of 8 atoms that certain materials may adopt as they solidify. So maybe the key here is you have to put 8 different type of metal alloys together in order to solidify it into this type of heat resistant shell. Well, the first known example was diamond. Other elements in group 14 also adopt this structure, including tin, the semiconductors silicon and germanium, and silicon-germanium alloys in any proportion. Again, the word alloys comes up. So here's a pole figure in stereographic projection. Now this is what the sphere is supposed to look like in the middle. It's supposed to be a little round ball thing, right? Of the diamond lattice showing the threefold symmetry along the 111 direction. June the 11th, 2012. My thoughts. This pole figure in stereographic projection looks exactly like the center core part of the UFO engine spaceship engineering design from my sketches. The visions, dreams, and actual UFO sightings of others. There are a couple videos back in line 17. If you look in line 17, you'll see the designs for the ship. You'll see other people's designs for the ship, and they're pretty close to being the same. These other people that did the designs are actual engineers that have worked for Area 51. They've worked for NASA, and now they work, I guess, for Russia and China and stuff. And they have the Russians have already made some sort of UFO, supposedly, according to the research that I found. So visions, dreams, and actual UFO sightings of others. Actually, on another note, this week, June 24th, if you look on the Victoria Stafford blog, I found out, or actually the ID Girl says WordPress blog, NASA's built this little tiny thing for the new Mars rover. They're sending this biological rover over to Mars. And it looks like a little tiny UFO, and it kind of tucks up inside of it, but it was pretty cool. It looks like a cute little UFO. I just thought I should tell you that. So in the first set of videos in this Wow Seti data, it shows us again line 17 and now in line 22 videos. Now this is a zinc blend unit cell. See how it goes? The two atom types form two interpenetrating face-centered cubic lattices. Oh, my air conditioning is blowing air in my nose, so it's hard for me to talk here. However, it differs from rock salt structure in how the two lattices are positioned relative to one another. The zinc blend structure has tetrahedral coordination. Each atom's nearest neighbor consists of 4 atoms of the opposite type, positioned like the 4 vertices of a regular tetrahedron. Altogether, the arrangement of atoms in zinc blend structure is the same as diamond cubic structure, but with alternating types of atoms at the different lattice sites. Examples of compounds with this structure include zinc blend itself, many compound semiconductors such as gallium arsenide and cadmium telluride, and a wide array of other binary compounds. The space group of this structure is called F43M in Hermann-Magruin notation, or 216 in the International Tables for Crystallography. The Struikberg designation is B3. Sulfurite on dolomite from the Tri-State District, Jasper County, Missouri, USA. Now this is what I would use in your outer shell. It looks like a good component. Sphalerite is a mineral that is the chief ore of zinc. It consists largely of zinc sulfide in crystalline form, but almost always contains variable iron. When iron content is high, it is an opaque black variety. Marmatite. It is usually found in association with galena, pyrite, and other sulfides, along with salite, dolomite, and fluorite. So there's the word fluorite again, right? We talked about fluorite in our last video. Miners have also been known to refer to sphalerite as zinc blende and blackjack. The mineral crystallizes in the cubic crystal system. See that? It becomes some sort of cubic thing. In the crystal structure, zinc and sulfur atoms are tetrahedrally coordinated. The structure is closely related to the structure of diamond. The hexagonal analog is known as Wurtz structure. The lattice constant for zinc sulfide and zinc blende crystal structure is 0.541 nm. Calculated from geometry and ionic radii of 0.074 nm zinc and 0.184 nm sulfide, it forms 8B CaABC layers. Here's another one that you're going to use. Sharp tehedral sphalerite crystals with minor associated caloprite from the Idaho Mine Telluride Ore District, Colorado, USA. A specific gravity of 3.9 to 4.1. Some specimens have a red iridescence with the gray-black crystals. These are called ruby sphalerite. The pale yellow and red varieties have very little iron and are translucent. So that's where you would get that see-through look from it. A lot of people say when they see spaceships, they're kind of see-through looking. The darker, more opaque varieties contain more iron. Some specimens are also fluorescent in ultraviolet light. The refractive index of sphalerite, as measured via sodium light, 589.3 nm, is 2.37. Sphalerite crystallizes in the isometric crystal system and possesses perfect dodecahedral cleavage. Gemi pale specimens from Franklin, New Jersey, see Franklin Furnace, are highly fluorescent orange and or blue under long-wave ultraviolet light and are also known as cleophane as an almost pure Xenon S variety. Again, that's from Wikipedia. Another sphalerite sample, that's what it looks like. So June the 11th, 2012, sphalerite. I'm going to Google it to see what it comes up with. Interesting, it brought up this. So what I did is I Googled it in my notebook to see if I've mentioned it before in another video, and I have. So we're in line 22, and it came up in line 18, A3Z 5B3C, tetrahydrite crystal skulls, cubic matrix resin copper foils. That talks about the power of crystal skulls. It also talks about different properties used with these other things too. So that was quite interesting. And I've got it on my blog here, so we'll just click on there. Yeah, there we go. So when I blog it, you'll be able to see it. Okay? Here's the blog post here. This is the blog here that I put my data up on with the WOW videos, and then I put the actual research notes with it as well, so that you can take a look. And these are all the videos that go with line 18, so if you're going to look at this one, you want to look at all these other ones too. And then there's, you know, the data, where I find it, how I find it, with the links there. So you just, if you want to look at a link, you just copy and paste it into your browser. Okay? And that's just the basic notes for that particular video. Okay, so with the keywords matrix and cube, it must be one of the materials you need to use for the core area of the UFO spaceship Central Command. Here's the other ones to look at. Okay, so I've copied the list from there. So line 18A3Z 5B all the way up to line 18A3Z 5B6. Okay? And there's all the different videos that are in that section. Again, it'll be posted on that link. Actually, if you go to April 17th, 2012 on the blog, over here, if I give you a specific date that it's blogged on, if you just go to April 17th and click on there, it'll give you a list of all the blog posts for that day. And then if you want to go to older entries, you see the words Wow Seti. That's always at the end of each video that I made. I also do blogging for weather predictions and ghost stories and stuff on here. But if you want to just look at the Wow Seti stuff, Just look for the word Wow Seti, click on it, and there you go. Okay? Quick reference there. So this was blogged April the 17th, 2012. So look close to that date on the calendar on the blog, and you'll be able to find all of them together there. Because I usually blog all of them together. If I've got a whole section that belongs together, they get blogged within the same date or within a few days of each other. Or in this case for June, within a month of each other. Keywords that stand out in line 18 videos are in line 22 videos. Tetrahedra plus hydrocarbon plus optical rotation plus argon gas plus fusion plus collision plus electron plus tetrahydrite plus wafers plus cubic plus matrix plus atomic plus fuels plus laser light plus resonators. So all these keywords are what came from the data on that particular line 18. So it talks about argon gas. We've got your fuel and your laser light beams and the atomic fuels. Again, a lot of stuff came up in line 21 about fusion as well. Line 21, 22 seems to refer to fusion, how to create nuclear fusion. Okay, so we'll go to the next one. I got a little bit of power left here. 22e5b